Okay, today we discussed about the given conditions to find average tensile stress. We noted the given conditions like diameter at section A, diameter at section B, and tensile load. We need to find average tensile stress at section A and also at section B. So you can write the unknown data in this problem. We can use the symbol sigma to represent normal stress. Normal stress includes both tensile and compressive. For shear stress, we can use tau. Okay, you can write it in your note. Very simple problem. After writing, you can use stress formula. What is stress formula? Stress formula.
Stress by area.
Load by area. Okay, you can substitute load value and area at section A followed by area at section B. Here same load is acting throughout the component. So 40 kilonewton is same at section A and section B. You can tell me your answer. First you can find area at section A. Okay, what about area formula? Area formula. You can, everyone, okay, you can post your answer in the chat box. We can see who are really participating in every discussion.
Pi by 4 into d square.
By d square by 4. By d square by 4. Here by dA square by 4. Sigma A sigma A and sigma B. Okay, we need to find these two unknowns. We know sigma formula. Sigma is equal to load by area. Area at section A. This is sigma A. Okay, we can use same equation for sigma B. Sigma B is equal to load by area at section B. Area at section B. A load value 40 into 10 power 3. Divided by area. Okay. Area. Did you find area? Area at section A. Area at section A. Area at section A. You can tell me your answer or you can post your answer in the chat box. And Kritesh, area at section A. Area at section A. Area at section A. Please substitute diameter at section A. And you can type your answer at the chat box. Your voice is not clear. Okay. Area at section A is 0.491 into 10 power minus 3. So what about stress at section A? Stress at section A. Jasmine, stress at section A. I request everyone to post your answer in the chat box. I can call everyone for single question, so you can post your answer in the chat box. Okay. Okay, Rajiv. If stress at section A is 81.4 into 10 power 6. 10 power 6 Newton per meter square. Newton per meter square. Okay, next stress at section B. Load by area at section B. Okay, Solomon, area at section B. Area at section B, Solomon. Solomon, are you here, Solomon?
Yes, ma'am.
Okay, tell me area at section B. Same formula. By dB square by 4. Others, you can post your answer. I like to see everyone answer. Okay. Yeah, I request others also to post your answer. You know the procedure. I told you very clearly. Everybody needs to answer when faculty say anything in the blended learning. Area at section B. Solomon, did you calculate the answer? 0.346 into 10 to the power minus 3 meter square. Sorry, this is area. 0.346 into 10 power minus 3 meter square. Okay. Next, we need to find the stress at section B. Stress at section B. You can calculate and post your answer. I think everybody is copying. Very good, Raj. Stress at section B. stress at section B, 115.6, 10 to the power 6 Newton per meter square. Okay, that's it. It's a very simple question. Here diameter is not given in the question. In the diagram only it is given. So we need to see the diagram also. It is very clear about the material steel. Our aim is to find only average tensile stress. You don't confuse yourself. Tensile stress at section A or average tensile stress at section A means we can use same formula. Load by area. Area will vary from section to section because section C is crude. So we calculated stress at section A, that is 81.4 into 10 power 6 Newton per meter square. 10 to the power 6 means mega Newton or 81.4 mega Newton per meter square. Okay, next. Similarly, we can tell 115.6 into 10 power 6 as 115.6 into 115.6 into 10 power 6 Newton per meter square can be written as 115.6 mega Newton per meter square. Okay, is it clear? Is it clear? Here you need to write even kilo also in simple form. Instead of kilo, we can use into 10 power 3. If it is mega, we need to write mega as 10 to the power 6. Jiha means 10 to the power 9. Okay, next problem. Only Jasmine, Aksha, Emmanuel, Rufus. Only these people posted the answer. What about others? Hashel. What about others? Everybody, okay, you can post your answer. Sarah, Anaka, Keya, everybody, Majish, Mabhishek. Okay, next problem. Is it clear? Shall we move to next problem? Is it clear? Do you have any doubt? What? Okay, now we can move to second problem. Okay, see this diagram. You can tell me how many sections in this bar, material of this bar, and the given conditions, unknown parameter. Augustine, can you answer? Given data, unknown parameter, material, about number of sections. Can you answer?
Ma'am, it has three sections. First section consists of diameter 25 mm. Second section diameter is 20 mm. Third section diameter is 25 mm.
Okay, in terms of meter, can you tell?
Its length is first First section length is 150 mm, second section is 250, and third is 150 mm.
Okay, in terms of meter, in terms of SI unit, can you tell me L1? L1 value. L1 means length of the first section.
Oh, 150 into 10 power minus 3 meter.
Okay, very good. Okay, next Afrin. Okay, Afrin.
Yes, ma'am.
Yeah, you can tell. The given data. Given data. He told you can include other parameters. Yeah, Augustine told diameter length of every section. What about other known parameter, known values?
D1 equal to 25 millimeter.
He told already. 25 millimeter means 25 into 10 power minus 3 meter. I want other given data.
Load of 40 kilonewton.
Okay. Load common or varying from section to section? See the diagram and try to answer.
Varying, ma'am.
Load varying, is it correct? Okay, Dharanish, is it correct? Okay, load 40 kilonewton. Is it common? Dharanish, is it common to all three sections or only to section 1 and 2, 1 and 3 or 1 and 2? Jerusha 53. Okay, if you fail to answer me, I can mark absent. I told. Okay. Load 40 kilonewton is applicable to section 1 or section 3 or
Excuse me, ma'am.
yes. Who called me? Okay, at the end of this class, I will create one assignment. Okay, you can take photo of your notes. What you taken today, you can submit the same before 5 o'clock. Okay, please listen the class. We know about the people mindset. Even in class, I can see some mischievous students. So we will have some policy to make everybody work during this online class. Okay, can you able to answer me? Anyone? Jerusha, at least you can post your answer in the chat box. Jerusha, Alna, Narpavai, you can post your answer. It is very difficult, okay, to hear your voice because I am also talking. You can post your answer in the chat box. I hope you drawn the diagram. You can answer whether load P is applicable only to section 1 or section 3 or section 1 and 2 or section 2 and 3 or section 1 and 3. Everybody can post your answer. I called some of you. You not answered. Sruvani, Narpavai, Alna, Jerusha, Dharanish. Are you here? Okay, very good. Load acting on the entire bar is 40 kilonewton. Okay, please listen. There are many cases on this bar. We can see uniform section, we can see varying section with the same load, we can see varying section with a different load also. But in this problem, we can see uniform loading 40 kilonewton on section 1, section 2 and section 3. So here total extension is given. Total extension of the bar is 0.28. Okay, Surya Kumari, okay, I think you talking with your friends. If you want to talk with your friends, okay, please leave this meeting. We not compel anyone. If you have the capability to understand everything, you can study in the hostel itself. Don't come for any more discussion. Okay.
It's not me, ma'am.
I only muted you. Okay. Don't argue. Do your work. A total extension. Okay. Del L. Okay. We can use del L. Del L. Del L. Total extension is equal to extension of the first section under load. Del L1. Del L1. Total extension is equal to del L1 plus del L2 plus del L3. Okay, del L formula. Any volunteer? Del L formula. Harish, are you here? Harish, number 47.
Yes, ma'am. Yes, ma'am.
Del L formula.
Ma'am, strain into length, ma'am. Hello, ma'am.
Strain
Hello.
into length. Okay, I
Yes,
given
ma'am.
okay, another formula. Okay, you are correct, but here strain is another unknown. So we can try another equation.
PL by AE, ma'am.
P
L by AE.
okay, PL by AE. Here load is common. So P instead of L we can write L1. First section length. PL by area. Area is not same. Okay, we can see varying section. Diameter is not uniform from section 1 to section 3. So A1. PL by A. What about Young's modulus? Young's modulus. Is it same or varying? Read the question, you can answer me. Okay, please listen. We can't assume everything. Similarly, okay, we can't have all the values in strength of materials or in any analytical paper. Okay, if you have some basic knowledge, we can fix something. It is not given anything about Young's modulus, uniform Young's modulus or varying Young's modulus. Simply they asked to find Young's modulus of the material. So we can assume uniform value or same material in every section. So E, capital E alone. Okay, very simple. Extension formula, extension or elongation formula is PL by AE. PL by AE. Here load is common, so we put P. Instead of P1, we put P. Length is varying. L1 is not equal to L2. So PL1 by A1. Area also not same. Individually, we need to find the area for every section. And Young's modulus, we can keep it as same. Okay, next, second section. Del L2. Del L2 value, del L2 formula. PL2 by A2E. Okay, next, del L3. Ebenezer, del L3 formula. Del L3 formula, Ebenezer. Del L3. Ebenezer is not attending. Muhammad asked, PL3 by A3E. PL3 by A3E. Okay. Okay. We need to first see whether the section is uniform or varying. If it is uniform, diameter is same in every section. But this is varying section or non-uniform section. So diameter is not same. So its corresponding area also varying. This is the idea. But here they not talked anything about same material or varying material. They simply asked us to find the Young's modulus, so we can assume same material is in every section. Okay, extension formula PL by AE. Somebody told del L means strain into original length. You are correct, but here strain is unknown. For finding strain also we need Young's modulus. So we can't jump into strain part. We can use the basic load extension relation PL by AE. Using this equation, we can find Young's modulus because del L is 0.28. Left side value is known. Load also known. L1, L2, L3 values are also known. A1, A2, A3 also known. So we can find Young's modulus. Okay. PL by AE, but it will change from case to case. In this case, we written PL1 by A1E. If load is varying, we can write P1L1 by A1E. If Young's modulus is varying, we can write P1L1 by A1E1. Okay, it will vary based on the conditions. But commonly we can say del L means PL by AE. Okay. Can you substitute and tell me Young's modulus value? Young's modulus value. Please substitute all the given conditions and you can answer Young's modulus. Young's modulus value. You can post your answer in the chat box. Okay, Iman. Muhammad Afra, yeah, I will get GMT attendance after this meeting. Yeah, I asked the questions. Partha Sarathi, may I know your answer? Young's modulus
Ma'am?
value. Young's modulus value.
Ma'am, 1 minute, ma'am, I'm working, ma'am.
Okay, you can post your answer directly.
Okay, ma'am.
Surya Kumari, please check your answer. Young's modulus value. Young's modulus value not correct.
Yes, ma'am.
You can post your answer. I will create assignment. Okay. Class assignment or blended learning class assignment 1 date 25 July. Okay, here you can attach your document. So please do it before 3:30. Before 3:30, not 5. Before 3:30, you can do this work. Or before 3 p.m. Okay, others you can post your answer. Young's modulus value answer. Laila, you can post your answer. Ren, Harith, Reguvel. Okay, request everyone to post your answer. Okay, I have one question. Can you answer me if it is compression? What about del L formula? If it is compression, del L formula, del L is equal to PL by AE for extension. What about compression or shortage or shrinkage formula? Can you able to hear me? Raju, unit Raju, Newton per meter square or Newton per mm square? Please mention the unit. Okay, can you answer me whether the same formula for compression? Anyone can answer. Emmanuel, can you answer me? Extension del L is equal to PL by AE. Okay, what about compression?
It should be the same.
Minus PL.
Okay.
Minus PL by AE. Okay, Harith not same. Okay, Raju, please check your answer. Unit. Okay, others you can post your answer. Okay, you and try to use capital N, Newton, capital Newton. Okay, correct. 2 into 10 power 11. Young's modulus value is 2 into 10 to the power 11 Newton per meter square. Okay, do you have any doubt you can ask? Raj, can you check your answer, Raj? Laila Mustafa minus L into E. What is this? I want Young's modulus answer. Delhi L, I told Ren, we can't use strain equation. For finding strain also we need Young's modulus value. Here Young's modulus is unknown. So we need to use only this formula, PL by AE. Okay, Sharon. Okay, next we can solve this problem. Can you write this question alone? The bar is subjected to the load as shown in figure. You can copy only first diagram. Find the total extension of the bar if the Young's modulus of the material capital V is equal to 200 GPa. Young's modulus value is 200 GPa. Okay, here we can see uniform cross section, varying cross section only. What is 20 into 40? Any guess? 20 into 40. Can you able to see the screen? What is 20 into 40? And the 10
Length into breadth.
Length into breadth.
Breadth into length.
Then what about 100? Here we can see 100, 100, 100. Usually cross section means width into thickness or width into depth. We know every object has 3 dimensions, length, width and depth or thickness. So here 20 into 40 means width into thickness, that is cross section of the bar of the first section. Length of the first section is 100. Here all dimensions are in millimeter. Okay, second section length L2 is 100 mm. Cross section is 10 mm into 40 mm. Third section length L3 is 100 mm. Its cross section A3 is 40 into 40 mm square. Okay, we can see some load. Whether it is uniform, can you check and tell me whether the loads are uniform? Sandhya, can you check and tell number 17 whether the loads are same from first section to third section? Are you listening, Sandhya?
Yes, ma'am.
Yeah, you can tell me whether the load is same or not same on every section.
No, ma'am.
Okay, first section load value. First section load value. The first section has two loads, 10 kilonewton on the left side, 50 kilonewton on the right side. Second section also. Okay, we can see 10, 50 on the left, 12, 28 on the right. On third section, we can see 28 kilonewton on the right. On the left, we can see 12, 50, 10. Okay, what about the direction of 10, 50, 12, 28? Rightward or leftward? Sheena, whether the member is under rightward force or leftward force, or leftward, rightward together. Sheena, are you here? Okay. When we
Yes,
start
ma'am.
this course, okay, we need to investigate everything. Chances are there for external question paper. If you are very clear in your basics, you can manage any question paper, IIT question paper also. That's why, okay, we need to check everything before solving this problem. We can see about cross section length, uniform or varying section. We can check same loading or varying loading. What about leftward force, rightward force on every section? Okay, we need to investigate everything before coming to the conclusion. In this problem, also we need to find the total extension of the bar. I will solve it in the next class. I think tomorrow we will have class. So I will solve this question in the next class. Very, very important question. Okay. Or I will give some idea. You can manage. Here actually we need to find resultant force on every side. What is resultant force? In engineering mechanics you studied. What is resultant force? What is resultant force? Resultant force, a very simple question. Rufus. Okay, Rufus, you are very particular in timing, Rufus. You can answer me. In my clock only 2:49. Till 2:50 I can go. Rufus,
Ma'am, resultant force is the
when you joined Rufus, did you join
ma'am.
sharp at 2 o'clock? I
Yes,
think you
ma'am.
joined after 2, 4 only. I can tell your
No, ma'am. 2-1 sharp at 2-1.
not sharp at 2 1. I will send. Okay, GMT attendance. Okay, you try to join on time, then I can also finish the class on time. Okay, resultant force means total force. Okay, we can come for further discussion in tomorrow's class. Thank you. Okay, please post your answers before 3 o'clock.